6 equal resistors of resistance R ohm each have been connected to form a triangle as in the figure. If R1, R2 and R3 are the effective resistances between A and B, B and C and between A and C respectively, then find the ratio R1 is to R2 is to R3. So here a triangular network is formed by using 6 resistors. We have 6 resistors, 1, 2, 3, 4, 5, 6. So all having equal resistances R ohm each. And it is given that R1 that is the effective resistance of the entire network between the terminals A and B. But here it is marked as R. What is R? That is only the resistance of that part between A and B alone. That is different from the effective resistance of the entire network between the terminals A and B. Similarly, R2 is the effective resistance of the entire network between B and C. Resistance of that portion alone is different from R2. And between A and C, the effective resistance of the entire network, that is labeled as given as R3. Now to solve this network, we just need to know how to calculate the effective resistance of a number of resistors connected in series and parallel. Let us analyze the network. So in this network, if you are considering the part AC, we know 3 R ohms are in parallel. So the total resistance of the part between A and C alone, that is 1 by R plus 1 by R plus 1 by R 3 by R, and 1 by R effective is 3 by R, so R effective is equal to R by 3. So this entire part AC, the entire arm, that can be reduced as R by 3. And similarly here we have 2 R ohms in parallel. So we know when 2 equal resistors are in parallel, their effective resistance will be reduced to half. 1 by R plus 1 by R is 2 by R, that is 1 by R effective is equal to R by 2. And we know when 2 resistors are in series, their effective resistance is the sum of their individual resistances, and when they are in parallel, their effective resistance is the product of their resistances divided by the sum of their resistances. Now if we wanted to calculate the effective resistance of the entire network between the terminals A and B, so we have to approach the network in such a way that, suppose first of all we have to keep AB there itself, then treat the other 2 resistors. We know R by 2 and the end of R by 2 is connected to R by 3, end-to-end connection. So R by 2 and R by 3, they are in series. So here R2 and R by 3, they are in series, so their effective resistance are R by 2 plus, this is R by 2 and R by 3, they are in series, so their effective resistance is R by 2 plus R by 3, so we are getting it as 5 R by 6. So this entire part that can be reduced to 5 R by 6. Now the AB, that part as it is, and that is having resistance R, that is in parallel with 5 R by 6. So what is their effective resistance? We know that is their product divided by their sum. So 5 R square by 6 divided by 11 R by 6 multiplying by the inverse, 6 and 6 cancelled, and 1 power of R in the numerator also cancelled. So R is totally cancelled from the denominator, so we are getting it as 5 by 11 into R. So that is given as R1. So we have expressed R1, that is effective resistance of the entire network across the terminals A and B, as 5 by 11 into R. So to calculate the effective resistance of the total network between B and C, we are keeping that side as it is and treating the other resistors, other 2 resistors, R and R by 3, they are in series. R and R by 3, they are in series, so their effective resistance R plus R by 3, that is 4 R by 3. Now we know this entire branch, upper branch, that is having a resistance 4 R by 3, that is in parallel with the lower branch BC R by 2. So what about their effective resistance? because they are in parallel, then we know that is their product of their resistances divided by the sum of their resistances. 4 into r square, 4r square by 6 divided by, and the simplified LCM is 6, 4r square by 6 divided by 11r by 6 multiplying by the inverse. 6 is cancelled, 1 power of r is cancelled from the numerator, and finally we are getting it as 4 by 11 into r, that is r2. So r2 is expressed as 4 by 11 into r. Now let us calculate the effective resistance of the total network between the terminals A and C. So between A and C, we are keeping that side as it is, r by 3 that side as it is, then treating the other two resistors. R, its end is connected to r by 2, end-to-end connection. R and r by 2, they are in series. So the effective resistance of this part, r plus r by 2, that is 3r by 2. Now this 3r by 2, that is in parallel with the side AC, that is r by 3. So what is their effective resistance? The product of their resistance divided by the sum of their resistances. So that is 3r square by 6 divided by, and then multiplying by the inverse. As usual, 1 power of r is cancelled from the numerator, and 1 power of r only retained in the numerator, and 6 and 6 is cancelled, so that is 3 by 11 into r. So the effective resistance between A and C, r by 3, that is expressed as 3 by 11 into r. Now what about the ratio of their resistances? The ratio of their resistances, r1 is to r2 is to r3, 5 by 11 r is to 4 by 11 r is to 3 by 11 r. Now r by 11 can be cancelled from all terms. So cancelling r by 11 from all terms, we are getting 5 is to 4 is to 3. The answer is option C, 5 is to 4 is to 3.